All right, we're going to begin lesson 4.5, and it's on arithmetic sequences. And the objective today is to be able to write and graph equations of arithmetic sequences. We're really going to not get into the graphing today, but we're going to look more at what these arithmetic sequences are all about, what they mean, and be able to identify them and be able to write them and use explicit formula to be able to answer questions about them. All right, so first of all, some terms and definitions. We start talking about sequences, and a sequence is simply a set of numbers that are ordered in a specific way. All right. Each number within that sequence is called a term of the sequence. And what we're going to work on today is an arithmetic sequence. And in an arithmetic sequence, each term after the first term is found by adding a constant. So it's constantly changing by the same value each time. That difference that is changing by is called the common difference. And it's the value that we're adding each time to get the next term in the sequence. Okay, so for example, let's say you were given this sequence set of numbers. Okay, so 15 is the first term in the sequence. Excuse me, negative 15. Negative 13 is the second term in the sequence. Negative 11 is the third term in the sequence. And negative 9 is the fourth term in the sequence. Okay, and then the fifth term comes after that, and the sixth term, and so on. All right, what makes this arithmetic is if I move from negative 15 to 13, I'm adding 2. If I go from negative 13 to negative 11, I add 2. Negative 11 and negative 9, I'm adding 2. So there is a common difference in that I add 2 every time to get the next term. So yes, this series is arithmetic, and the common difference is 2. Okay, so that's what it means to be an arithmetic sequence is we change by the same value each time, and that value we change by is called the common difference. Okay, so one type of question you'll get tonight is this. For each sequence, determine whether it appears to be arithmetic. If it does, find the common difference. So looking at the first one, negative 9, negative 15, negative 21, negative 27, is this one changing at a common rate every time? Well, negative 9, negative 15, if I subtract 6, negative 9 minus 6 is negative 15. Negative 15 minus 6 is negative 21. Negative 21 minus 6 is negative 27. So this sequence is arithmetic, and the common difference, that D, is negative 6. How about the next one? 4, 20, 100, 500. Well, from 4 to 20, add 16. From 20 to 100, if I add 16, this is not 100, right? 20 plus 16 is 36. So this is not an arithmetic sequence. It may be some other type of sequence, but it's not arithmetic, and that's the question. So it's not an arithmetic sequence, and if it's not, then you can't find a common difference. Down here, negative 10, then negative 6, then negative 2, then 2. All right, so what's the difference here? Well, I'm adding 4. Negative 10 plus 4 is negative 6. Negative 6 plus 4 is negative 2. Negative 2 plus 4 is positive 2. So yes, this one appears to be arithmetic. It's changing at a constant rate, and that constant or that common difference is we're adding 4 each time. Okay, so that's identifying and naming the common difference. Here's another one. So they give us 3 terms of the sequence. Find the next 2 terms of the sequence. So obviously we're looking for the common difference. So 31 to 25, that's minus 6. 25 to 19 is minus 6. So our common difference is we're subtracting 6. So the next term, which would be the fourth term, is going to be 19 minus 6, or 13. And then 13 minus 6 will be 7. And then 7 minus 6 will be 1. So the next 3 terms would be 13, 7, 1 after 19. Okay, next one here, negative 9 to negative 4, negative 4 to negative 1. So negative 9 plus 5 would be negative 4. Negative 4 plus 5 would be 1. So our common difference is we add 5 to get the next term every time. So the next terms would be 6, because 1 plus 5 is 6, and then 6 plus 5 is 11. 11 plus 5 is 16. Okay, the next one here, 18, 25, 32. So what are we doing? Add 7, add 7. So our common difference is add 7. So after the 32 would come 32 plus 7, 39. 39 plus 7, 46. 46 plus 7 is 53. Okay, pretty simple. All right, now there is a way, given an arithmetic sequence, to write an explicit rule. We're actually going to write these tomorrow. I want to show it to you today and let you use it a little bit. But tomorrow we're going to really work on writing them and understanding what that does. All right. So, okay, looking at this, the nth term of an arithmetic sequence. All right, so the nth term means you pick any number you want to put in place of the variable, the 10th term, the 12th term, the 18th term, the 21st term, whatever term you want to find. So this thing is a way of generating the terms of a sequence, and I'll show you what all that means a little later. All right, so to find any term of the sequence with the first term of a sub 1 and a common difference of d, we would use this formula. All right. So this a sub n is, this a stands for arithmetic. So the arithmetic sequence of whatever number we want to pick is found by taking the first term of the sequence and adding to it the number of the sequence term, which is our n minus 1 times the common difference. Okay. So this is a formula you need to get familiar with. And we're gonna write it down because we're gonna use it. So to find any term in the sequence, we take the first term of the sequence and add to that the number of the sequence term minus 1 times the common difference. And that will generate any term we want in the sequence. And you'll see why we want this in a little bit. All right. Now, what happens is, because there's a constant rate of change, that common difference, plus 4, plus 4, plus 4, plus 4 between each term, that means the graph of any arithmetic sequence is going to be linear. It's going to be a straight line. Okay. N in this case is going to be our independent variable, which is the x. It's our input. So n is our input. That's what we're choosing to put in place of the equation. A sub n is the answer. It's the output. So the a sub n is the answer when I put the first term and whatever number I'm trying to find into the equation. I get an answer of a sub n. That's my output. That's my y. And then d winds up being the slope, the common difference, right? Constant rate of change is a straight line. All right. Now, this stuff we're going to do more with tomorrow. I'm just kind of getting it out there right now. But you're going to work with this formula today. Okay. So let me show you. So let's say they give us this explicit rule. A sub n is equal to 38 minus 5 times n minus 1. And they're asking us to use this rule to find the first 4 terms of the sequence. Okay, if you remember back, all right, 38 is actually going to be our first term of our sequence because a sub 1 goes here. Minus 5 is actually acting like our d, our common difference. And then n minus 1 is how we generate our answers. Let me show you how this works. So if n was 1, so this means I'm finding the first term of the sequence. All right, then the way we would do this is we would substitute 1 in place of the n's. So it becomes a sub 1, which means this is the first term of the sequence, arithmetic sequence term number 1. To find that, I put 1 in place of n. Okay, so I rewrote the equation with 1 in place of the n. So a sub 1 equals 38 minus 5 times 0. A sub 1 equals 38 minus 0. A sub 1 is 38. Well, we knew that already because we knew this a sub 1 was right here. Let's find the second term of the sequence. To find the second term, I'm going to put 2 into this formula. So a sub 2, the second term of the arithmetic sequence, 38 minus 5 times 2 minus 1. Okay, again, I'm in place of my n's, I'm putting 2 there, and I'm putting 2 in place of the n in parentheses. Okay, so 38 minus 5 times 1, 38 minus 5, the second term is 33. Okay, want to find the third term of the sequence. So substitute n in place, or excuse me, 3 in place of the n. So a sub 3 is the third term of the arithmetic sequence we're looking at, and 3 goes in place of n. So 38 minus 5 times 3 minus 1, 38 minus 5 times 2, 38 minus 10. The third term is 28. And then the fourth term of the sequence is when I let n equal 4. So put 4 in place of the n's here and here. So this a sub 4 is the fourth term of our arithmetic sequence, and this will tell me what it is. Okay, so it's 38 minus 5 times 3, 38 minus 15, 23. So the first 4 terms of this sequence are going to be 38, 33, 28, 23. Okay, and now we knew that because we knew the first term was 38, and we knew the common difference was minus 5. It's all right here that we can see. But the explicit formula which is a formula that will generate the answers for us. We use it for a lot more than finding the first four terms. So we're just showing you how it works right now. Okay. So you want to learn how to use it. Don't try to shortcut this to the problem here. Let's do another one. Okay. So here is a explicit formula. A sub n equals 49 plus 8 times n minus 1. We want to find the first terms of the sequence, four terms. So we're going to use 1, 2, 3, and 4. All right. So the first term of the sequence, let n equal 1. So a sub 1 equals 49 plus 8 times 1 minus 1. 49 plus 8 times 0, 49 minus 0. The first term of the sequence is 49, but we really already knew it because that number right there represents the first term of the sequence. Second term, 49 plus 8 times 2 minus 1. We're going to put 2 in place of the n's, and we get 57. Just working the math here, right? Third term of the sequence, substitute 3 in place of n. 49 plus 8 times 3 minus 1. 49 plus 8 times 2, 49 plus 16, 65. N equals 4. Put 4 in place of n. So 4 here, 4 there. 49 plus 8 times 4 minus 1. 49 plus 3 times 8. 49 plus 24, 73. Okay, so the first four terms of this sequence, 49, 57, 65, 73. What's the common difference? We're adding 8 every time. Okay, what was the first number of the sequence? 49. We can get that right out of the formula. Okay, but here's the beauty of it. If I were to ask you for the, I don't know, let's say the 50th term of this sequence, do you really want to go 49 plus 8, 57 plus 8, 65 plus 8, 73 plus 8? Keep doing that until you get to the 50th one? Or would you rather just put 50 in place of n and get the answer? That's the idea. That's where this thing really comes into play. All right. So that's our work for tonight. Those are the problems you're going to focus on. All right. So make sure you write some of that down so you have the information to use. And the homework is on Alex, and I will let you get at it.